Hey guys, this is Alan with Bothell STEM Coach, and today we are continuing on with the AP Calculus free response questions, and here's the last calculator question, number 3. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives the values of the functions and their first derivatives at selected values of x. The function h is given by this. Explain why there must be a value r, 1 less than r less than 3, such that h of r equals negative 5. So h is equal, well, let's compute the bounds. H of 1 is equal to f of g of 1 minus 6. G of 1 is 2, so that's f of 2 minus 6. Because g of 1, I replace it with 2. F of 2 is 9. 9 minus 6, that's equal to 3. H of 3, f of g of 3 minus 6, that's equal to, what's g of 3? G of 3 is 4, so that's f of 4 minus 6. F of 4 is negative 1 minus 6, it's equal to negative 7. Okay, so you see function h, see, because by intermediate value theorem, because over this range from 1 to 3, we went from 3 to, so this is by intermediate value theorem, it must have crossed through negative 5 as long as it's continuous. Is h continuous? F and g are differentiable, so that means they're continuous, because they can't be differentiable unless they're continuous. So when f and g are differential, they're both continuous, hence this thing is continuous, so when I subtract 6, it's still continuous. So by h is continuous, and that implies negative 5. Basically, it implies that it has to have gone gone through negative 5, because it went from negative 3 to negative 7, and it couldn't have skipped over number negative 5. And that's the intermediate value theorem. Okay, B, explain why there must be a value C such that h prime. So with slopes, you're looking at mean value theorem. So let's look at the derivative at 1. The derivative at 1, well, let's first compute what the derivative of h of x is. H prime of x is equal to the derivative of this. That's f prime g of x, then by chain rule, g prime of x minus 6. So when you take the derivative of f, you just do the derivative with the same, you don't touch the inside. And then if the inside's not just x, you got to multiply by the derivative of the inside. That's kind of how chain rule works. So h prime of 1, for example, is equal to f prime of g of 1 times g prime of 1 minus 6. That's f prime, g of 1 is 2, so that's f prime of 2, g prime of 1 minus 6. F prime of 2 is 2, g prime of 1 is 5 minus 6. That's 10 minus 6, and that equals 4. H prime of 3 has to be f prime of g of 3, g prime of 3 minus 6. That's f prime, g of 3 is equal to 4 times g prime of 3 minus 6. F prime of 4 is 3. G prime of 3 is 4 minus 6. So that equals 12 minus 6. That's equal to 6. G prime of 3 is 2. I don't know. That's 0. 4 to 0. No, I did this right. So f prime of 2 is 2. G prime of 1 is 5 minus... Oh, derivative 6 is 0. I don't know why I'm doing this 6 here. So this is 10. And this is... So let's get rid of the minus 6. G of 3 is 4. F prime of 4 is 3. G prime of 3 is 2. 3 times 2, that equals 6. Huh. It shouldn't be. That's G2. I don't think that has to be 1. Did I compute this correctly? Oh, I'm just looking at the sorry. I'm using intermediate. I'm not supposed to be doing the derivative. That's probably later. What I'm supposed to look at is the slope of h. So the slope here between 1 and 3, the secant line slope, h of 3 minus h of 1 over 3 minus 1. This is the secant line slope. That's equal to -7 minus 3 over 2. That's -10 over 2. That's -5. So by the mean value theorem, because it's differentiable and continuous, by the mean value theorem, there has to exist a value where the tangent line slope is also, this is the secant line slope between the two endpoints. There has to be, so if you kind of think of just as a random curve, well, actually it's a -5 slope. So it's like something like this. Let's put more curve on here. Like this slope here, this is 1, this is x equals 1, x equals 3. Okay, this is a secant line slope of this curve h. Okay, because this slope is -5, there has to be somewhere along here, because it's differentiable, that like the slope, the tangent line slope equals -5. That's the mean value theorem. So mean value theorem for the second one. Okay, see, let w be the function given by this. Find the value w prime of 3. So w prime of x, by the fundamental theorem of calculus, the derivative of this is just f of g of x. Okay? Like if this were x, you would just say it was f of x. But because it's some other function of x, it's f of g of x. And then by chain rule, because this part's not x, you got to do g prime of x. Okay, f of g of x. So w prime at 3 is equal to f of g of 3, g prime of 3. G of 3 is 4, so that's f of 4. G prime of times g prime of 3. That's f of 4. F of 4 is -1. G prime of 3 is 2, -2. Okay, and d. If g inverse is the inverse function, write an equation for the line tangent of the graph y equals g inverse of x at x equals 2. Okay. I don't remember. There's a formula for the inverse, but the way I would do it is I would say, well, I know g of y is equal to x, right? Because if g inverse of x equals y, so then what I do is I take the derivative of this equation. I get g prime of y times dy dx by chain rule has to equal 1. So that tells me dy dx is equal to 1 over g prime of y. Okay. Now, when x equals 2, g inverse of 2, y is equal to g inverse of 2. So I want to know what value is the y. So when I do, see, g of 1 is 2. Like g of 1 equals 2. So therefore g inverse of 2 is equal to 1. Right? Because that's kind of what inverse is. So this is 1. So this is, the slope is 1 over g prime at 1. G prime at 1 is 5, so the slope is 1/5. Okay? So that's the slope. I'm going to erase all of this stuff real quick just to make room. So some people memorize the derivative of inverses and stuff. I just do it by implicit differentiation here to solve it. So then I have y is equal to 1/5. X, I do point slope form for line tangents. X minus x naught, the point is x equals 2, plus y naught, the point is y naught was 1. So that would be the equation of my line. Okay. So let's take a look at how we did. So this is continuous by the intermediate value theorem. There exists an R. This is H is continuous and differential by the mean value theorem. There exists a C. Okay. This was -2, which I got. And this is y minus 1 equals 1/5 x minus 2. I brought the 1 to the other side. So I got the same thing there. So yeah, I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.